Uh, Hello. Am I audible?
Yes, sir. Good evening, sir.
Good evening. Good evening to all of you. So let's wait for some time. I think people are joining. Is the city session finished or is it going on? Okay, so we'll wait for some 2 to 3 minutes, then we'll start this session. Meanwhile, can you tell me how many of you covered the week 12 content or is it still going on?
Sir, still going on.
Okay, how many lectures you have covered?
Sir, 12.3 lecture.
Okay, okay. Then I think then what we'll do, I will give you the some kind of summary kind of of all the concepts of week 12. Okay. Will that be fine for all of you? So we'll do the we'll try to understand the concepts of week 12. Okay. Will that be fine for all of you?
Yes, sir.
Okay. Okay, then let's wait for 2 to 3 minutes, then we'll start the session. A city session is finished or is still going on?
Sir, it's going.
Okay. Okay, is it about to finish or it will take some time?
So it will take some time.
Okay. Okay, no worries. Let's wait for 2 to 3 minutes, then we'll start the session.
Sir, can we ask graded assignment questions?
Which week?
Week 10. Sorry, 11.
Okay. What is your doubt?
Sir, I have a doubt in one of the question. Here it is, there it is given that the variance, about the variance and the standard deviation,
Your voice,
one of the
your voice,
option. It is given that,
yeah,
yes,
your
sir.
voice is breaking.
Okay, let
Yeah,
me
just
try again.
yeah, just try. Okay, well, uh, let's start the session. Okay. So, Palak, just fix your voice and then we can discuss it. Okay. No problem. Or else
So
we
is
can
it
discuss.
now okay?
Yeah, it's okay. Yeah, tell me, then we'll.
So
Hmm.
yeah, there one of the options is given that the variance would be greater than or equal to standard deviation, and
Hmm.
the second option is given that variance should be less than or equal to the standard deviation. So
Okay.
I take the option that variance should be greater than and equal to the standard deviation, but it's wrong. But I do not get why.
Okay. What was the question?
So the question is, what which of the following is the correct option?
I mean, any information before that, or is the only which of the following is?
No, sir. I think no information is given. It's
No,
week 11, graded
there
assignment,
should be
question number
something,
2.
right? There should be something, some information, some distribution or something else, right? Or
No,
is,
sir.
is it? Let me check then. Is this x follows binomial and p? Hello, are you talking with the question number two?
Yes, sir.
Yes, sir.
That question, yes,
So
sir.
it's just given, right? X follows binomial. You are saying it's a nothing. Okay, so you can simply take one example, right? For example, let me share my screen. Okay. So this example, right? So it says x follows binomial and p. So then which of the following statements are always true? N is greater than 0 and p is between 0 and 1. So you can simply cross check, right? For example, suppose you have, let's say I'm saying I have n is equal to 3 and p is equal to half, for example. Okay. Then what will be the variance of x? Okay, first of all, expectation of x. If x is binomial, then n into p,
It's n into p.
right? 3
Yes, sir.
into half. What about variance of x? N
Yes,
into
sir.
p into 1 minus p. That means 3
And
into half into half. So here you can see simply check expectation of x is always greater than variance of x, right? So this option is correct. Let's say you are talking about variance. For example, here variance is what? 3 by 4. What will be the standard deviation of x here? It will be square root of 3 by 4. That means square root of 3 divided by 2. Yes or no?
Yes, sir.
What is the value of square root of 3? It's a 1.73 something like that, correct? Divided by 2 is what? Tell me, what is the value?
0.86.
0 point. And what is the 3 by 4? It's a 0.75, correct? So which one is the greater,
Standard deviation.
right? And actually here we are talking about is or always true, right? So for always, this should be correct option, right? It can vary according to the some numbers and all. Okay, so actually it's about always. Okay, so we will upload the graded assignment solution. Okay, don't worry, then from there you can simply cross check. Did you get the idea, right?
Yes, sir.
Okay, yeah. So I mean, you can take any different example where standard deviation is less than something like that. Okay, so for example, you can simply check. Okay, let me my screen is okay. One second. Yeah. Okay. For example, see here you can see standard deviation is what? It's a greater than of your variance of x, right? Yes or no?
Yes, sir.
Okay. For example, I'm saying x follows binomial. Let's say n is 16, p is half. Then what will the variance of x here? It will be n into p into 1 minus p, which is nothing but 4. And what will be the standard deviation of x? Square root of 4, which is 2. So here you can see standard deviation of x is less than or equal to variance of x, right? So it's a varying, right? So as I mean, it will you will get the different as per the values of your n and p. So if you see question, it is asking about always, not about maybe, right? So it's about always. So expectation of x will always be greater than variance of. Is this fine? I think Palak, right? Palak, is it okay?
Yes, sir. Got.
Oh,
Yes, sir. Got it. Yeah.
okay, so let me start the week 12 content. How many? Okay, can you raise your hand? How many of you covered uh, all the videos or at least 3 to 4 video? One, this has raised hand. I think she told me in the beginning of she has covered 3 sessions, 3 lecture video. What about others? Yes, no, anything? Not yet. So, how many lectures? Okay, let me start. Let me start the content, sir. So, I'm going to give you the summary of week 12. Okay, will that be fine, right? Assuming if you have not covered the week 12 content, so I will give you the summary of week 12 content. Okay, and then we'll see some examples. Okay. So in week 11, right? So you have seen the something about discrete random variable, right? Means what is the PMF for discrete random variable, CDF of discrete random variable, and all everything. Yes or no? Correct? Then some probability and conditional probability and all you have seen. But what about continuous random variable? That is the question. I mean, can I do the same thing about continuous random variable? And is there any thing where like I can move from means from where you got the idea of continuous. Okay, so let me give you one uh, something. Let me define. Try to explain so that you will get some idea from where we are moving to the continuous. Okay, actually, okay, in discrete random variable, right? You may have seen, right? PMF, right? PMF is probability mass function. Correct? That is the full form of PMF. Yes or no?
Yes, sir.
And in probability mass function, what we are saying, I will be having one random variable. It will take some value, let's say x1, x2, xn. And what I'm saying, for each value of x, there is some probability associated with each value, right? Yes or no? And we know what is there is some criteria, properties, like all the probabilities should be greater or equal to 0, and it should be summation of all the probabilities should be equal to 1. Correct? These are the two basic criteria to be like valid probability mass function. Yes or no? And how did we define CDF? CDF means if you say it's a cumulative distribution function. Okay, I will go in little bit depth for continuous. I mean, from where we are uh, got the this idea. So basically, how we are defining f of x? It's nothing but probability x less or equal to x, right? Basically, see here in this case, we are interested in probability. What is the x will take x1? It's a p1. Similarly, probability x will take x2. It's a p2, right? So here we are interested at a single point. What about if I'm interested in a till a point, right? What is the probability that x will take value? Let's say till x3, for example. Then what you have to do? I have to add all the probability till x3, right? Yes or no? So that means what? What we are doing? We are basically we are accumulating. We have to accumulate all the probabilities till x3 or x whatever. So basically we are accumulating all the probabilities, right? So till this point, that is something CDF has been defined. Yes or no?
Yes, sir.
Now let me take one example. Suppose I'm saying x follows discrete uniform. Okay, let's say discrete uniform. I'm saying 0, 1, 2 up to 50, for example. Then what will the probability X will take value 0? Yeah, tell me. What is the probability for discrete uniform? You've done discrete uniform distribution, right? I think in week 10, week 11. What is the probability X will take value 0 in discrete uniform case?
One by n.
Okay, what is the discrete uniform? Anyone can remember?
Like probabilities for each outcome is equally likely.
Yes, that is the definition of uniform, right? So I'm writing like, okay, suppose tell me what is if X will take value 1, 2 up to n, then probability associated with each value if 1 by
One
n,
of
1 by n, this is called something uniform distribution. Yes or no? Discrete uniform. Correct? Yes or no?
Yes.
Right? Then tell by using this information, if I'm saying X is following uniform distribution, I'm saying discrete uniform, this is 0, 1, 2 up to 50. Then what will the probability at a single point? Probability at X equal to 0?
1 by 50.
Just think a little bit.
1 by 51.
1 by 51, right? Because see here n values are there, right? Here 51 values are there, right? From here it's a 50 and including 0 it's a 1 by 51, right? What about probability X equal to 1,
1 by 51.
right? Similarly, for each probability, right? Probability X equal to 2 up to so on up to probability X equal to 50, right? Now, tell me what about if I will ask probability X less or equal to 2,
3 by 51.
right? It will be probability X equal to 0 plus probability X equal to 1 plus probability X equal to 2. So it will be 1 by 51 plus 1 by 51 plus 1 by 51, which is nothing but 3 by 51, right? So, so what I'm trying to explain here, you, you have seen, right? If f is 10 to plus infinity, it will take value 1, right? That is something you have seen or not,
Yes, sir.
right? CDF can take only two values, right? I mean, limit minimum is 0, maximum is 1, correct? So what is the meaning of that? Suppose I'm saying if I will ask probability X less or equal to 50 means what? This means I have to add all the probabilities, right? X equal to 0 plus up to X equal to 50, right? It will be 1 by 51 plus 1 by 51 plus up to 1 by 51. You will get 51 divided by 50, which is 1. So this means what? F of 50, right? Yes or no?
Yes, sir.
Yes, sir.
Okay. What if I will say, tell me F probability that X less or equal to 51? X is taking only value how much? Till 50, right? I can say probability X equal to 51, right? So this is not in the sample space. So probability for this, it will be 0. Again, you will get 1. Yes or no?
Yes, sir.
Okay. Similarly, probability X less or equal to 55. Again, it will be,
Sir, so how so it's not taking probability of x is equals to 51?
did you see this one?
Yes, sir.
Yeah, so it's outside the range, right? It's a impossible event. X is
Okay.
taking only value till 50,
Right, sir.
right? So tell me about this. What is the value? It will be again 1, right? again you will add whatever till x equal to 55, it will take all, I mean, after 50 it will be 0, right? So what I'm trying to say, what is this? This is, can I say, capital F of 55? Because f of x, how we are denoting? Probability x less or equal to x, right?
Yes, sir.
So what I'm trying to say, so that's why you can say f can take maximum value 1. Okay, that's why you have seen that fx can take value 0 and 1. Okay, that is something I'm trying to say here. Okay, let me give you another idea here. Okay, I will come to that point. Maybe that is useful as point of in continuous. Okay, but let me explain in discrete. So then after that I will connect through the continuous. So there is something. If I will say A is lying between, I mean A is more than any constant A and less or equal to B. Any one of you can think what will the value for this? Okay, suppose let me give you the. Suppose I'm saying this is the A and this is the B, a point, right? And X is here. So what I'm saying, X is more than A. That means after here, okay? But less or equal to B means still here. If I need this green region area, green thing, how will I get? Can I get something like that? If I will be having, right? So if, so from this whole region, whole red region, correct? If I will subtract this brown region till A, I can get the green region. Yes or no?
Yes,
Yes,
sir.
sir.
Okay. So basically, can I say, so what is the red? Red is nothing but probability X less or equal to B. Yes or no?
Yes,
Sir.
sir.
And if I will subtract probability X less or equal to A, just try to understand. It will helpful. It will be helpful while you will see normal distribution and all. It is very helpful for that. Okay. Is this okay to all of you? To get a green thing, right? I have to subtract from red minus brown. What is the red? Probability x less or equal to b. What is the brown? Probability x less or equal to a. Is this all right?
Yes, sir.
So that means what I can say, probability a less than x less or equal to b. This is nothing but, can I say, f of b minus f of a. This is the CDF itself, right? So far so good,
Yes, sir.
right? Now let me change a little bit more. Suppose I'm asking probability A less or equal to X less than or equal to B. So here what is the change? You can see here one less than equal to sign has been added. That means what? Can I say probability A less than X less or equal to B, the previous one, right? Then what is the extra? Extra we have added a equal to sign for A. So can I say plus probability X equal to A? Is this same? Yes or no?
Yes, sir.
Right? So what is this value? This is the from equation number 1. Again, I can say it's nothing but f of b minus f of a plus probability x equal to a, right?
Yes, sir.
Okay. Now, tell me one more thing. Suppose I'm saying probability a less than x less than b. What about it? This? What should I write? Tell me by using the previous information.
Sir,
So what? Yeah,
probability of A less
less than
than X
x
less than B.
less than or equal to b, correct? Because I will have this information. So what is not here? Equality of at b is not here, right? So what should I write here? If I will
Sir, subtract
correct. If I will subtract probability x equal to b, I will get this thing. Is this fine? Right? Now you can simply put this value right here. Okay. Now tell me for this. If I will write probability a less than or equal to x less than b, then so this is the helpful. I will tell you when
pro,
we will move to the, yeah.
probability Probability of A less than X.
less than B, correct? We can use
Yes.
simply, right? Because if you know this value, you can simply say plus probability,
Probability X is equal to A.
right? This is something we can do. Okay. So just keep in this mind, just you can basically keep this in mind, and accordingly you can add and subtract. Okay. I will let you know what's the importance for this. Okay. Once we'll move to the continuous word. Okay. Now, if I will take this case itself, x is follows uniform. It's a discrete uniform. I'm saying 0, 1, 2 up to 51, right? Then what if I ask 3 less than x less or equal to 5? Tell me. What does this mean? What should I write?
Probability 3 less than probability 3
Why 3?
less than x.
What is okay? Just think like this. What is this?
A and
No, forget about above formula. I'm just asking in general. This means what? X will take
x
what
should be
value?
greater than 3 or less than 5 or equal to 5.
Tell me what should I write? That is my question. How will you find this
3,
probability?
3, 5.
What is my question? Suppose I'm saying x follow discrete uniform with this case. What is the probability? 3
Okay,
x is
okay.
greater than 3 less than equal to. Then what
4,
should I write?
4 and 5, so 2 by 51.
Correct. That is my question. Okay. This means this case, right?
Hmm.
Okay. So basically 1 by 51 plus 1 by 51, which is nothing but 2 by 51. Okay. This is something you can use by this. What if I will use this formula?
Sir,
Correct. I can use the above formula also. 3 less than x less or equal to 5, right? So what this means? This means f of 5 minus f of 3, right? Okay.
Yes, sir.
This means 5. What if f of for f of 5 means what? X less or equal to 5 and probability x less or equal to 3, right?
no, sir,
For
only
x
less than.
less than or equal to. What I'm saying, I have written this one.
Okay.
See, this is the same case, probability A greater than, sorry, x greater than A less or equal to B. So I'm saying 3. So can I write this f of 5 minus f of A? Understood?
Sir, can you repeat the formula again, sir? Because it's a bit confusing.
Okay, what is this case? This is nothing but this green region, right?
Yes, sir.
After A till B, right? So
Hmm.
to find the green region, what should I do? How will how I can find this green region? If I will subtract
Total probability.
red minus brown, right? So what is
Right,
the
sir.
red? Red is x less or equal to B, and what is the A? X less or equal to E. Correct?
Right.
So that is something. So this formula is helpful. Okay, I will let you know. This is very helpful when we will move to the continuous part. Okay. So, but we need to understand here itself. Okay. Is this fine? No?
So, but um, okay,
Mhm.
the above question is different. Where it's
No,
given
no.
uniform.
One second, one second.
Hmm.
Yeah. Go ahead, go ahead.
So the x is given that x uniform distribution
Hmm.
0 to 51 in the range of 0 to 51. So I'm taking that
Hmm.
50.
Hmm.
So here we are taking 5 and 3, right?
Okay. What
5.
does this mean? First of all, tell me. It simply means x is more than 3. That means x can take 4 and it's less or equal to 5. That means it will take only these two value, right?
Yes, sir.
So we have to add these two probability. That's all. I will get this probability.
Sir, but the below one, it's like we have to subtract from whole range to that particular
Yeah,
two.
I want to use the formula. See, what is this case, right? I want to use this formula. This is the same thing, right? Can I write this was? This is something formula which I had written. Yes or no? Correct?
Yes, sir.
So if I will write probability 3 greater than 3 less than x less or equal to 5, that means I can simply write probability x less or equal to 5 minus probability x less or equal to 3 by using this
Mm,
formula. Instead
right,
of
sir.
B, I have 5. Instead of A, I have 3, right? Okay.
Right, sir.
So what is the probability x less or equal to 5? By using this information, means we have to add 0 plus 1 plus 2 plus
1,
3
2,
plus 4.
3.
That means 6 by 51. It is starting
5 by
from 0.
51.
It is starting
Sir,
from 0.
5 by
Equal
51
to
now.
5. नहीं 6 by 51 होगा. Equal to 5 है ना?
Yeah. Okay. See,
Hmm.
0, 1, 2, 3, 4, 5. How many values are there? 6, right?
Mm-hmm.
And for 3, 4 by
4 by
51.
51.
What we got? 2 by 51. So if you see, you got the same answer, right? Nothing difference. Okay.
Okay, sir.
Fine. Okay, so let me move ahead. Okay, okay. So what you do is you can just keep in your mind this formula. Okay, basically this is very helpful when you will see the normal distribution part, right? Normal distribution, exponential, and all. It is very helpful. I will come to that one. Don't worry. So what I'm trying to move ahead for how continuous things comes into the picture itself. Okay, so okay, tell me if x follows uniform, right? Then I will be having 0, 1, 2 up to 50, right? Then I can simply, suppose I will ask probability x less or equal to 49. You can simply tell me, you can add all the probabilities and you can tell me the values, right? Yes or no?
Yes, sir.
Yes,
What
sir.
if I will ask x follows discrete uniform, let's say 0, 1, 2 up to, let's say 1000. Then, and I will ask probability x less or equal to 9, let's say 992, something like that. So will you do the manually? Will you add all the probabilities manually, or will you try to move something else?
Sir, we move
Sir,
something
it
else.
will be n plus 1 upon 2.
You
Like,
are telling me the expected value. I'm not asking that one. What is the my question? Okay. So if this is the case, if this is something, you can simply tell me, what if x less or equal to 992? It's a very tedious task, right? It will take some time and it's a little bit tedious and difficult work, right? Yes or no? See, adding
Yes.
all the values, right? There is a chance you can make some mistake. So what we are doing? So what we are expecting? So we are okay with some kind of, we will do some approximation. We are okay with some. Just try to understand what I'm trying to say here. So we are okay with some kind of error, some approximation. So that's why actually continuous comes into the picture. So in continuous, what we are doing, we can simply approximate the thing, right? Rather than adding and all, right? So in a continuous, we get the approximate thing. What I mean by like that, okay. Suppose I want to, you'll get an idea. If x is discrete uniform, right? 0, 1 up to 50, okay? Tell me one thing, all of you. Suppose this is the x and this is the, for example, suppose this is your capital Fx. Capital F of x means it denotes the CDF part. Okay. If I will ask, so this is the 0. Suppose this is the 1, this is 2, this is 3, this is the 4, this is 5 up to, let's say, some 51, for example. So for 0, okay. So let's say this is the 1 by 51, then this is the 2 by 51. For example, this is the 3 by 51. Just suppose this is the 4 by 51. This is suppose 5 by 51 up to, suppose 1 is there. Okay. Now, what is the probability at x equal to 0? X less than 0, it will take 0. At x equal to 0, it will be like this, 1 by 51 till here, right?
Yes, sir.
At x equal to 1, it will be again from 2 by 51 till 2. Then from 2 onwards, it will be 3 till 3. Then 4 by 51. Then for 5 by 51 and so on. At 51, it will be 1 to 1 onwards, right? This is something we are drawing CDF plot for a discrete random variable. Yes or no? Yes, no. Is this clear?
Yes, sir.
Is it okay to all of you, right? What I'm trying to say here. If I will ask, okay, tell me, if I will ask what is the probability at x equal to 3, that means what? This jump we are asking. So value at this jump, it will give you the probability, right? What is this probability? 4 by 51 minus 3 by 51, which is nothing but 1 by 51. So this is something we will get at a single point, yes or no?
Yes, sir.
Right? Are you getting what I'm trying to say here? Okay.
Yes, sir.
If I will
Yes,
ask
sir. Clear.
what is the probability at x equal to 4, this that means this jump, right? What is
Mhm.
this jump? Probability x equal to 4, it's a 5 by
4.
51 minus 4 by 51, which is nothing but 1 by 51. Or else you can understand by this formula. What is the probability x equal to 4? I can simply say probability x less or equal to 5 minus probability x less or equal to no, at x equal to 4, right? Sorry. So you can simply write x equal to 4. So you can simply write x less or equal to 4, right? Minus f x less than 4, right? Only then you can find x equal to 4. Are you getting? Let me write. Only I will get the probability x equal to 4. Yes or no? Are you getting this point? See, this means what? X equal to 0 plus probability x equal to 2, 1 plus up to probability x equal to 4 minus probability x equal to 0, then plus probability x equal to 1 up to probability x. So this all this will get cancelled. You will be having this one, right? See, you need equal to equal sign at x equal to 4. This means what? X less or equal to 4 minus x less than 4. Are you getting my point?
Yes, sir.
Okay. So this is the same thing, right? So far, so good. Now, is this fine, right? I will move then a little bit.
Sir, could you please explain last part again?
Okay, so this means what? How will you find this probability x equal to 4? This jump means what? See, probability x equal to 4 means what? Okay, tell me. Okay, let's go by probability x equal to 1. Tell me probability x equal to 1. This jump you will be doing 2 by 51 minus 1 by 51, right? Which is 1 by 51. So probability
Yes.
x equal to 1, when you will get, when I can probability x less or equal to 1 minus probability x less or equal to 0, or simply x less than 1. Okay, just try to understand the equation. Okay, what is the probability x less or equal to 1? That means probability x equal to 0 plus probability x equal to 1
Yes.
minus probability x less than 1 means x equal to 0. Okay, so if you see, this will get cancelled out and you will be having this only, right? So that is something I'm writing in general. Is this fine now?
Yes.
Is this okay for everyone? Yes or no?
Yes.
All right, right. Okay. Okay, so what I'm trying to say now, okay, suppose it was for 50. Suppose I will increase x follows discrete uniform 0, 1, 2 up to 1000 or 10,000, something like that. Let's say 10,000. Then I will get the graph, CDF graph, something is about, let's say 10,000 or 1,000. Let's say 1,000. Then I will get 1 divided by 1,001, something here. Then 2 divided by 1,001. Then 3 divided by, I mean, I will get my CDF graph like this or not? Very, very close, right? Yes or no?
Yes, sir.
So actually, I will get approximately continuous curve, right? There will be no jump, right? Here you can see very little jump, right? For 50 itself, right? When it will be 1,000, whenever you will be having large sample, right? I will be moving to the continuous part. That is the main idea here. Are you getting? So here you can see CDF. I mean, your graph will be like this. Very small jump or approximately no jump, something like that. You will get graph. Are you getting my point?
Yes.
Yes, sir. Okay. So in continuous, the CDF graph actually, you will get something like this. I mean, something like this. It can vary as per the function itself, but at one it will be something like. Okay. So what you can see. Okay, if suppose this is the 0, this is 1. If I will ask, let's say this is value A. If I will ask what is the probability x equal to A, can you tell me?
Probability
X
x
equal to A.
minus
No, what will be the value of A here? Probability at X equal to A. Tell me the value. Anyone? Can you think?
0
Okay.
plus 1 plus so on up till A.
What I'm asking, if here, how did you get the probability X equal to 3? You just simply calculated the jump, right?
Yeah.
From this point to this. Is there any jump in this curve?
no, sir.
Can you find probability at a single point?
No.
Right? If I want to find the probability at this point, is there any jump?
No, sir.
Okay. So that's why probability at a single point is a 0 in case of continuous random variable. Okay. So when we are moving to the continuous part, we are okay with some approximation, some error. Actually, you had seen PMF of your discrete random variable. After PMF, okay. After PMF, we calculated the CDF, right? CDF of your discrete random variable, right? And then discrete random variable, if I will increase our sample size, right? Then I got the CDF of continuous curve, right? CDF of continuous random variable. Then after CDF, we will be moving to the PDF of continuous random variable. Actually, this CDF, right? This CDF is a bridge between discrete to continuous. You can see, right? You can see from the PMF, we move to the discrete CDF of discrete random variable. Then we found that whenever we'll increase, then we will move to the continuous and something like that. Okay. So this is just an idea of continuous. You may have seen probability at a single point will get the 0 in case of continuous. So this is something how we are doing. Okay. So here if you see, okay, some rough idea is okay for everyone. Yes, no?
Yes, sir.
Yes.
So suppose for any function, your graph is like this, for any function, right? For any continuous function, okay? So what I'm asking, suppose, okay, in the previous CDF graph, if I will ask what is the probability 3 less than equal to x less or equal to 4, you can simply calculate all the values, right? If I will ask here, suppose this is the point A and this is the point B, then if I will ask what is the probability that X will lie between A and B, right? Then actually what we are doing in continuous, so we can make a some, you can say it's you can see this line, right?
Strips.
Yeah, strips. Very, I mean, it's a, I mean, all interval actually. So what we are doing actually, in case of continuous, you can see, you can simply make this strips and all. So what we are doing, we have to see, we have to do continuous summation, which is called something continuous summation. So what is the continuous summation basically? So we can simply integrate. Basically, this integration is called continuous summation. It means suppose this is the fx, right? Any function is there. So what we have to do, we have to add this part plus 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 this part. This is something called, so this is called continuous summation. If this is the case, that's why we are moving to the integration part. Actually, integration nothing but a continuous summation. Okay. So this is what we have to do. We have to fx and dx. So this dx is nothing but this thing. Okay. So we are not going into that mathematics actually. So whenever we have discrete random variable, right? If okay, we took that example. If you will be having this case, for example, just suppose x is discrete, then what we will do? You will simply add 3 plus x equal to 4 plus x equal to 5, right? If you will be having continuous, then you have to integrate inside under that particular range, right? That is something I'm trying to say here. Is this clear how we are moving from discrete to continuous?
Yes, sir.
Sir,
Yes.
sir, why the probability is 0 at a particular point.
Okay, how will you find the probability here? Here, this is probability what? You are finding the jump, right? You are
Yeah,
subtracting the value. In the case of continuous, is there any jump?
there is no jump.
No jump, right? You can't subtract from any value, right? Or if you go by mathematically also, right? If you have something a to b fx dx, and if you want to find probability at x equal to a, that means what? You have to integrate from a to a, right?
Yeah.
Anyway, at the end, you will be get 0, right? F of a minus f of a, right?
Yeah.
Okay, that is something. Okay, fine. Actually,
Sir, excuse
yes,
me.
yes.
Sir, the last one which you showed, like, yeah, yeah, this one. Is this a continuous?
Yeah, this is the continuous curve, right? In discrete, you can't get like this. In discrete, you will get something like this. Some jump will be there, right? In continuous,
Yeah.
there will not be any jump. Okay,
Sir, so then it will be zero, right? Entirely.
entirely zero. Why?
In the
In
sense like
it
this will
will
be
be
zero, no?
one,
The probabilities if we add it will be zero, right?
one. You are trying to say one probability. See, whenever we had discrete, right, probability mass function, we know probability should be greater or equal to 0, and summation of all probability should be equal to 1.
Yeah,
Okay,
yeah,
yeah. So here in case of continuous, probabilities will be greater than 0. Integration area under the curve, it will be 1. Minus
yeah.
infinity
Got it.
infinity, I'm
That's what.
writing minus infinity infinity. It's not minus infinity, it's about minus infinity infinity means I'm talking about whatever the range of your random variable will be, right? So area under that curve, it will be 1. That is the sum. Okay,
Yes, sir. I thought actually it would be zero. Then
no,
how
no,
will
it's
it
not
be
about
zero?
0.
Like, yeah,
No, no, it's not 0, it's 1.
yeah. Got
Okay,
it.
okay, so any one of you can tell me. So we are moving to the called PDF. Okay, actually, I should simply discuss. Maybe you are getting bored. I'm just trying to say something here. Let's come to the PDF. So it's called probability density function. Okay, full form PDF is density. So why we are calling density? In density means what? Anyone can tell me? What do you understand by the meaning of the density?
Mass by volume.
Yeah, mass by volume, right? So density is what? Mass by volume in physics, basically, right? So here volume we are treating as a mass by area. Okay,
Yes, sir.
fine. Okay. So let me go with that case. Actually, what I'm trying to say here, basically, how will you find? Uh, okay, suppose I'm saying here itself. Okay, suppose for example, how we are getting this case probability a less than x. Basically, it's nothing but area within that this interval, right? And divide by total area. Correct?
Yes, sir.
Okay. So we know anyway, if you see probability is what? So total area will be 1, right? Okay. And how we can compute area within this interval? Area within a comma b, this is nothing but this case. Means we have to simply do the continuous summation, that is something integration of fx x ds. So I'm just till now I was just trying to understand to to make you understand so that you can get idea how we get this integration part. Okay, I can directly start with this part, but I thought you should get some idea how we are getting the continuous and all. Okay, so far is it fine for everyone?
Yes, sir. Clear.
Right, clear. Now initially we in discrete case, right, I wrote one formula probability a less than x less than or equal to b, we got f of b minus f of a, right? Or which I wrote probability x less or equal to b minus probability x less or equal to a, right? Yes or no, everyone? This was we wrote, right? Yes or no? Are you? Yeah, if you are not getting, you can simply say it's no, right? If you will not speak anything, I will simply assume you are getting the things. This is the case we got for the discrete random variable, right?
Yes.
Okay, if it is a continuous, right? So can you see? So probability at a single point, it will be 0. right? This part will be 0, right? Probability at a single point. Yes or
Yes.
no? So that means you will get this thing only. If you come to this point again, so probability at a single point, again it will be 0. You will get this case only, the previous one. And probability, if you see fourth case, so again you see probability at a single point it's 0, you will get the same thing. So what is the meaning here? In case of continuous, equality doesn't matter. So whether you are writing this like this, you will get the same thing, f of b minus f of a. If I'm going to write probability less or equal to x less than b, it nothing but doesn't matter, it will be again f of b minus f of a. And fourth, probability a less than x less than b, again I will get the f of b minus f of a. Because whatever you are going to add or subtract at a single point, probability will be 0. Is this clear?
Yes.
Yes,
Yes, sir.
Okay. So this is actually very helpful while you will move to the exponential continuous uniform and normal distribution. I will let you know why. Okay. So far it is fine.
So
Okay.
your voice is breaking.
Now is it okay? Is it for everyone or is it?
No, sir.
I
It's
mean, no.
clear for me, sir.
Okay, clear. Okay. So this is clear, right? This is fine.
Yes, sir.
Okay.
Yes.
Now, great. Okay. Let me. Okay. What about if I will ask CDF f of x, then probability. Let's say f of a. That means x less or equal to a. That means I have to integrate from lower range till a, that PDF, right? PDF of that random. Yes or no?
Yes, sir.
Okay. Now let's start the thing which we the distribution part, okay, which is important, and then I will let you know the whatever all the history which we have till now. What is the agenda behind
sir.
that? Okay. Yes.
Sir, why did you take minus infinity? Can the random variable take negative?
Okay, it's about
Why
values,
can't it
not one second. It's
be
about
zero?
values. It's not about probability. This means, okay. First of all, and second thing, minus infinity means whatever the lower limit of your x is there.
Uh,
Okay. This is
sir,
not a probability. This is the range of array x. Okay.
can it be negative?
It's a range. I'm not talking about probability. Probability cannot be negative. I'm asking about this is the range.
Not
Okay, tell
not
me.
the probabilities.
Okay, okay, one second, one second.
Its
Suppose
value. Random variable.
you have not done the discrete case properly. Suppose I'm saying x is taking value minus 2, minus 1, 0, and with probability 1 by 4. Is this possible or not?
Yes, sir.
Is it correct or
Yes.
not? Tell me. Is it okay?
Yes.
Yes, no, anything. Who asked? I think this
Yes,
question.
sir. Yes, it is okay.
Someone had doubt, right? I think Kiran, you had doubt.
Yes, sir. Yeah.
It's fine, right? It is possible, right? Here, I think you are getting confusion. It's a probability. Probability is positive, right? Its values can take anything, right?
Probability is positive. That is okay, sir.
Hmm. Okay, values can be anything, right? You can define your function like this also. Suppose you are
We are
getting any,
defining any curve, right, sir?
yeah, you can define any function. Suppose this is 0 and you can take this is the minus 2. It can take value minus 2 to anything, right? Fine.
Yes.
Okay, so here f of a means you are asking, suppose a is here. For example, a is here. Okay, so that means you have to calculate this probability, right? Means minus 2 to a, you have to integrate the PDF. That's all. All right. Okay.
Yes.
So now we are moving to the continuous random variable, and the very first thing is called continuous uniform distribution. So by the name, you can see it's a uniformity is there, right? It will take a same value throughout the range. Okay, so let me just give you a graph so that you will be having some idea. So suppose this is the, so what is the meaning of it will take throughout there? Suppose I'm saying this is the A and this is the B. So suppose this is the sum K. So it will take value throughout this from A to B, K, right? That is something, it's a constant value, right? So that is something what, if I will say, so should I derive the PDF formula? Is it fine to all of you? Let me derive for this. I will not do the for. Okay. Tell me one thing. So what I will say, what is your function is taking? It will take value K, right? If X is lying between A and B, yes or no? It will take value K, right? Throughout this from A to B,
Yes, sir.
right? Okay, let's try to find the PDF formula. So how I can find this? So I have to integrate from A to B fx dx, and we know area under the curve should be equal to 1, right? From here, this will imply A to B. What is the value of f of x? It's a k, right? K into dx equal to 1. Or else from here we can see k A to B 1 into dx equal to 1. So k, and it will be x, right? Integration of A is nothing but x. This is the case. So it will be k. We have to subtract from upper minus lower limit. It will be 1. It will be k is equal to 1 upon b minus a. Actually, this is the CDF of your, PDF of uniform distributions. What we are saying, if x follows continuous uniform with parameter a and b, then PDF of uniform distribution will be 1 upon b minus a. And range is a less or equal to. Is this clear? Right? So this is something we are getting the PDF formula of your uniform distribution. Is this all right?
Yes, sir.
Okay.
Sir,
Yes.
if the strip is taken from like the y-axis,
Which
so
strip?
integration of the y-axis
Hmm.
instead of x-axis, if it's taken at y-axis, then k dy, right?
Yeah, we are not going into that part. Actually, I'm just I just here explained how we are getting the PDF of your uniform distribution. Okay.
Okay, okay. Got it.
Understood. Well, this is the something PDF of uniform. Okay, so uniform distribution you will study exponential and all. Okay, let me tell you the CDF form. So CDF is nothing but I can denote f of x, right? So this means what? Probability x less or equal to x, right? If you want to find the CDF of uniform distribution, so okay, tell me. Let me derive for this. I will let you know. Then I will move to the next part. Okay. So what do you mean by this probability x less or equal to x? How will you find this case? Tell me. Anyone? How will you find this probability first of all? In general, tell me.
Integration of
Integration
capital
of,
X.
not capital,
Yes, f of
integration
x
of the
dx.
PDF
Yeah, the
from where
limits,
to
sir,
where?
limits.
From where to where?
Capital X to x or small x to capital X.
Just think, let's see, capital X is not a value here. Capital X is your random variable. It will
Yeah,
go till
variable.
small x. Small x is the value. So from where to where it will go?
minus infinity to x.
Will it be minus
Minus
infinity?
infinity to x.
Will it be minus
So,
infinity?
sir,
Just think.
so limits are not defined here.
I'm talking about continuous uniform. In continuous uniform, limits is there.
Oh, yeah, to
It's
b.
A to B. What will be the limit? Tell me. This is the upper limit. It will go for sure till x. That means we have to integrate
0 to x.
y0
So a to x.
a to x, right? See, this is the uniform, right? Here a, here b. I'm asking what is the x. I'm
Oh,
I'm
yeah.
interested till x only.
Got it,
Okay,
got it.
just whatever you are saying, just think whether you are right or not, right? Okay, is this clear? So this is your upper value. Your random variable is going to take, and lower limit is not there. That means you have to take whatever the lower limit of your random variable. Fine. Is this all right? Okay. So we have to integrate. So it will be a to x. What is the PDF of uniform distribution? It's a
1.
1. What is the PDF of uniform distribution?
1 by b
1 by
minus a.
b minus
1 upon b minus a, right? This is the PDF we got. Okay. This is dx. If you see 1 upon b minus a, I can take outside, it will be 8 2x 1 into dx, right? So 1 upon b minus a, and if you integrate this, I will get
Nice.
x a to x. So that means if you put x, it will be x minus a divided by b minus a. So this is the CDF of uniform distribution which you have to keep in your mind. So this is the CDF of your uniform
So your
distribution.
voice is breaking.
Is it for everyone? I think, or is it okay?
Guys, it is off.
For me, it's okay.
I think, can you reach it? I think it's okay for others. Okay. So this is the CDF of your uniform distribution. Okay. Fine. Okay. So this is something you have to keep in your mind. So what is the, okay? If I will say x follows uniform with parameter a comma b, then what is the PDF? Small fx is 1 upon b minus a, right? And if I will
So,
ask what is the, yes, CDF
can you repeat it because I got disconnected
from where?
from previous.
This
Yeah,
part.
CDF. Yes, sir.
Okay. So CDF is defined as probability x less or equal to x, right?
Hmm.
Okay. So probability x less or equal to x means what? I have to integrate till x, right? Yes or no?
So why you write x minus a upon b minus a?
I will come to that point. What I'm saying here,
Yes.
you have to integrate till x, right?
Yes, sir.
Correct. So what is the lower
Yes.
limit? Lower limit is a in
A.
case of uniform, right? So I have to integrate a to x fx dx,
Hmm.
correct? And what is the value of
Yes.
fx? It's 1 upon b minus a. Understood?
So
This is the
how?
this is the PDF of uniform distribution, right?
Okay. It's given. F of x is equals.
Right?
So it's given, right?
Okay, have you seen any lecture video of week 12?
No, sir.
Yeah, that's why. Okay, have you understood this case?
Yes, sir.
So what is this? What is the value of k?
We integrate 1 by
This
b by b minus a.
initially I took f of x as a k, right? This k. And
Hmm.
I integrated, I got the value of k as 1 upon b minus a. So this is the PDF of uniform distribution. Okay, 1 upon b
Okay,
minus a.
sir.
Fine. See, if I'm saying x follows binomial distribution, then what is the PDF of, sorry, PMF of binomial distribution? N choose x, p raised power x, 1 minus p raised power n minus x, right? Similarly, in case of continuous, we will be having the PDF, which is called probability density function for whatever distribution is there. So for continuous uniform distribution, this is the PDF form which we have derived there. Okay.
Okay, sir.
And to calculate the probability, we are okay. If this is the discrete case, you will be adding the values, right? Let's say probability x equal to 0 plus probability x equal to 1 plus probability x equal to whatever, right? But this is the continuous case. We can't add. We have to do this integration. So I will be doing a to x fx dx, right? And what is the fx? Fx is 1 upon b minus
1
a.
upon b minus a.
Since it is a constant, I can take 1 upon b minus a outside.
Yes, sir.
It will be a to x 1 into dx. So now integration of 1 is it will be x, right? Because this is the
Right, sir.
dx. Then if you will put upper limit minus lower limit, you will get x minus a divided by b minus a.
Hmm.
So this is the CDF of uniform distribution. That's why I wrote here. Okay. So this is something you
Okay,
can
sir.
keep in your mind. Okay. So I wrote if x is the follows, then PDF is x follows uniform distribution a comma b. PDF is 1 upon b minus a, and CDF is x minus a divided by b minus a. Okay.
Yes, sir.
Fine. Now, so I will tell you why this is the important, because suppose I will ask, tell me the value. Okay, suppose I'm saying x follows uniform 2 comma 4, for example. Then I will ask you, tell me the probability that it 2 comma let's say 6. What is the value that x will be like this. Now tell me, and suppose you don't know the integration, for example. So actually the above formula which we have discussed, right? Then you don't know the integration and you know the CDF formula, right? In week 12, suppose you know the integration, that's very good. If you don't know integration, that's also good. Without using integration, you can find the probability, but you to keep in your mind the CDF formulas and all. Okay. So what should I write here? Tell me.
Integration
Okay, let's do
4
it. So integration from
f of 5
integration from
4 to 4 to 5.
why 4? It's a continuous.
so 3 to 5.
3 to
Yes,
5.
see, suppose you are getting any continuous curve. I'm asking 3 to 5, right? In continuous, can you separate the jump? No, right? In case of continuous, probability at a single point is 0. Okay, so equality and doesn't matter. Okay, so you to just integrate for 3 to 5. Okay, understood? So this is fx dx. Fine.
Yes, sir.
Okay.
Yes.
What is the value of f of x? Tell me, what will be the value of f of x? If this is continuous in form, then it will be fx will be 1 upon b minus
B
a. What
minus
is
a
b?
6 minus 2 4.
1
4.
upon 4, right? So this is the PDF, right? It will be 1 by 4 dx. Yes or no?
Yes.
Yes.
It will be 1 by 4. I can take outside. It will be 3 by 3 to 4. Sorry, 3 to 5. 1 into dx, right? Now it
Yes.
will be 1 by 4. It will be x 3 to 5. You have to put the
Right.
limit. So it will be 5 minus 3 divided by 4, which is 2 by 4,
2.
which is half. Fine?
Yeah.
So how 1
Yes.
by 4?
What is this? X follows continuous in form 2 comma 6.
Yes, sir.
What is the PDF of uniform distribution? 1 upon.
B minus A.
What is the B?
6.
What is the A?
Mm.
1 by 4. Okay.
Yes, sir.
Now, okay, so in the previous case, right, I have written one formula. If probability A less than x less or equal to B, if x is the continuous random variable, every scenario I will write f of B minus f of A or not. If this is the case, ax less or equal to B, again I will write f of B minus f of A, right? If probability A less or equal to x less than B, again I will write f of B minus f of A. If this is the case, A less than x less than B, again I will write f of B minus f of A, right? Irrespective of the equality sign, because in this case, if you'll add probability x equal to A, right? Then probability at a single point, we know it's a 0. So anyway, I will get the same thing in all the cases. Yes or no? Right?
Yes.
Yes, sir.
Suppose you don't know the integration and you have to calculate this part. Okay. By using the above case, probability 3 less than x less or equal to 5, I can write this as a f of 5 minus f of 3. Fine.
Yes, sir.
Let's
Yes.
make it equation of star. What is the, if I'm saying, if x follows uniform a comma b, right? Then PDF is 1 upon b minus a. And what is the CDF? We calculated x minus a divided by b minus a, right? Yes or no?
Yes,
Right,
sir.
sir.
So can I put the value here? What is the f of 5? And I told here x follows uniform 2 comma 6. Tell me what is the f of 5? So it will be f of 5 minus f of a. Sorry, f of 3. So what is this case? X minus a. So what is the x here? X is 5.
5.
5 minus a. A is how, what?
2.
2.
2. Divide by b minus a. That means 6 minus 2, which is
6 minus 2.
minus. This is the 3, right? So 3 minus, see, if you see, this is x, right? So here 3. 3 minus 2 divided by 6 minus 2. Yes or no?
Yes, sir.
So what will get? 3 by 4 minus 1 by 4, which is 2 by 4, which is half. Is this the same answer?
Yes.
Okay. So you can do the same thing without using integration. Suppose you don't know the integration, by using the CDF formula as well as this properties. Is this clear? Why we have studied in case of discrete and why we are moving here? Is this fine? Suppose you know the you in your mind CDF formula is there, you can simply calculate this value rather than doing the integration. Yes or no?
Yes, sir.
Is this all right for everyone, right? Okay.
Yes.
Okay. Now, okay, just I'm giving you one. Everyone has pen and paper.
Yes.
Yes, sir.
Okay. Suppose I'm saying x follows uniform. Let's say 10, 20. It's a continuous uniform. And I'm saying, tell me the probability is 5 less or equal to, oh, sorry, not 5, 15 less or equal to x less or equal to 18. Tell me value of this. You have, I will be giving 2 minutes. Okay. Just solve it and keep, I will ask you after 2 minutes.
So what we have to find, CDF or PDF?
Okay, so some of you are writing the answer 3 by 10. Let's see. Okay. Now you will tell me, I will write. First of all, what will the PDF?
1 by 8 minus 8.
1 by,
20 minus 10.
that means 1 by 10, right? And what will the CDF? In general, x minus a divided by b minus a, right? Okay. So if we solve this probability 15 less or equal to x less or equal to 18, right? We will see some example also so that you can relate with this. So it will be f of, I can simply written 18 minus f of 15, right?
Yes, sir.
What is this case? So it will be 18 minus 10 divided by 20 minus 10 minus 15 minus 10 divided by 20 minus 10. So far so good, because a is 10, this is a, and b is 20, and x is this value, correct?
Yes.
So it will be 8 by 10 minus 5 by 10, which is nothing but 3 by 10. So 3 by 10 is the correct answer. Is this okay for everyone? Did you get the idea? Yes, no?
Yes, sir.
Yes, sir.
Yes, sir.
Now,
Yes, sir.
one more thing. Okay, I will come to that part. Let me see, is there any question regarding this uniform, so that you will get the idea what is this something I'm trying to say. Just a minute. Let me see if there is any activity question related to that. It's the variance. Okay, maybe here it will be. uh, okay, well, let me. Okay, what? Let's do the very first question. Okay. The length of statistics lecture has a continuous uniform distribution between 50 and 52 minutes. That means what? If x denotes length, let's say I'm saying x is the length of statistics class. Okay. So what it is saying, x is continuous uniform from 50 to 52 minutes, right? This is something it's given to us, right?
Yes.
If one such lecture of statistics is randomly selected, find the probability the lecture length is more than 51 minutes. That means what? What is it asking? More than 51 minutes? That means what? Which
X
probability you have to
should be
find?
greater than 50 and less
X should
than
be greater than
52.
51, right?
Yes.
X should be greater than
Yes, sir.
51. Since we know the CDF, right? CDF is what? It's nothing but probability X less or equal to X, right? This is something greater. Can I write this as a 1 minus probability X less or equal to 51?
Yes.
I can, right? See, probability of A complement nothing but 1 minus probability of A. Yes or no?
Yes, sir.
Right? So 1 minus, what will the CDF part tell me? CDF is what? X minus A divided by B minus A. So what is the X here? X is
51.
51 minus
50.
divided by
50.
52 minus.
52
minus
minus.
50.
So it's a 1 minus 1 by 2, which is nothing but 1 by 2. Correct? So 1 by 2 is the correct answer. You can check. So 1 by 2 is the correct answer. Now, did you get it? Okay.
Yes.
Okay.
Yes, sir.
Just do the next question. Okay. Don't just click on the check answer. Just do the next question and tell me how will you proceed. Or should I do? If you want, I can do. Okay, let me do itself so that you can get idea. Okay, suppose that total duration of a test cricket match between any two cricket team is uniformly distributed between 90 and 450 overs, right? Both inclusive means I'm including 90 and 450. What is the probability that duration of a test cricket match between two cricket teams is more than 400 overs? So first of all, what is the X? X following continuous uniform from 90 to 450, right? And it is asking about what is the probability that it will be more than 400, right? Yes or no? I can simply write 1 minus probability X less or equal to 400.
Yes, sir.
Correct? Then 1 minus X minus A. So X minus 90 divided by 450 minus 90. If you solve, whatever the answer you will get. Okay. Again, question can be framed as for the, let's say, I'm saying what is the probability that a test duration of a test cricket match will lie between, let's say, 100 and 300 overs. Then what you will write? X lies between 100 and 300 overs, right? Yes or
Yes.
no? Then by using that property, I will simply write f of 300 minus f of 100. Yes or no?
Yes, sir.
Correct. Then f of 300, how will you write? 300 minus 90 divided by 450 minus 90 minus 100 minus 90 divided by 450 minus 90. You will get the answer. That's all. Is this clear?
Yes, sir.
Okay. Well. Now you have seen the expectation. Suppose I'm saying X is the discrete random variable, for example, then how we are defining expectation of X? Summation of X into Px, right? And variance of X, we know expectation of X square minus expectation of X whole square. Then how we can find? Then expectation of X square we are calculating normally, which is nothing but summation of X square into Px. Yes or no?
Yes, sir.
So in case of continuous random variable, suppose X is continuous random variable, right? Then expectation of X is nothing but instead of summation, we are going to use the integration sign, which is X into Fx dx. And for the variance, we know we have to calculate this because anyway expectation of X we have calculated. So it will be integration of X square Fx dx. So this will be variance, it will be expectation of X. This is something we have to do. Yes or no? Okay.
Yes, sir.
So here, what you can do, you can just keep in your mind, if you solve this for continuous, right? If X follows uniform, continuous uniform distribution with parameter A and B, this is called parameter. Then expectation of x, right? If you will solve, right, you will do a to b x into fx dx, right? So what is the fx? It's a to b x into 1 upon b minus a dx. If you will solve this, right? So at the end, expectation of x you will get. I'm not going to do this derivation. You can simply, if you solve, you will get expectation of x as a plus b divided by 2. Okay. Similarly, if you solve for variance, so variance of x will be b minus a whole square divided by 12. Okay. So this is something you can keep in your mind. This is the expectation of continuous uniform distribution. This is the variance of a continuous uniform distribution. Fine. Okay. We are not going to the derivation part. You can simply do and you can find the variance and expectation. Is this all right?
Yes, sir.
Okay. Okay, till now expectation is clear. Then CDF part and all, this part and all. This is something which we have done. Yes or no?
Yes, sir.
Okay, great. Now, next I'm trying to explain, it's called exponential distribution. So,
So so in previous slide,
hmm,
so can you scroll up?
hmm,
So what we did after down.
hmm,
बस यही ex square is equals to x square fx dx.
hmm.
We are not deriving it, right?
Yeah, we are not deriving. You can simply derive like this. I'm just telling you.
Okay.
If you derive, right, so if, what you do in case of uniform itself, you will do like this, x squared into 1 upon b minus a dx, right? Then you will get some value, right? After that, by
Yes.
using this variance formula, you will get some value. You have expectation of x, you will subtract the square of, you will get the this formula. Okay, so our main focus is you can keep in your mind this formula itself. Okay, for your interest you can do the
Okay.
simply derivation. I'm not going to do that integration because we have to see the exponential and normal and all. Okay, fine.
Okay, sir.
Okay, yeah. So next is exponential distribution, something called, this is also kind of continuous distribution, because like see this exponential distribution is helpful when like, see, normally we are interested something where this exponential distribution arises. Let me write something. This exponential distribution arises, you can simply this, I'm writing exponential distribution often arises as the distribution of the amount of time until some specific event occurs. So here we are interested in amount of time, so until some specific events occur. That means what? Let's say you are interested, you know some, you can define some x is the length of a phone call, right? In minutes. So that will, you can treat as a length of a phone call in minutes as an exponential distribution. Okay. Then something, let's say life of a battery. Okay, life of battery is some exponential distribution or something like that. So it's something where amount of time. So it's a basically this is helpful or useful. Maybe you can search something inter-arrival time in queen theory and survival time. Like something will be whether this let's say something is there, whether this thing will survive till this point or not, something like that. Okay, so we'll try to see more examples related to exponential distribution. Meanwhile, let me try to explain. So PDF and all. So if I'm saying, see, in case of continuous, we have seen the PDF is 1 upon b minus a, CDF is x minus a divided by b minus a. If I'm saying x follows, we are treating x follows exponential random variable with parameter lambda. So this is the called parameter. Okay, this is the parameter. Then and this lambda is greater than 0. So what is the PDF? PDF is nothing but it's always lambda into e raised power minus lambda x. where x is greater or equal to 0. That means x will take value 0 to till infinity. Let's say life of a bulb. Okay, life of a bulb, you can simply say life of bulb, right? It can be greater or equal to 0, right? It can last, we don't know at what time, right? But it will be more than equal to 0. Yes or no? Okay. So this is something whenever we are interested in some survival time or distribution of time until some specific events occur, something like that. So this is a form of the PDF of exponential distribution. Now, what is the CDF? CDF is what? F of x. What is the CDF? This is something I can write probability x less or equal to x, right? Yes or no? Yes or no? If you
Yes.
want to derive the PDF, how will you write this? So I will write integration part, right? Fx dx. So from where to where I need to integrate? Tell me. Yeah, what range should I take?
A to x.
Why a to x? Where is a is there?
0 to x.
0 to x, right? Lower limit of x is 0, right? X is greater or equal to this 0, right? And upper limit of this random, see, this small x means one specific value. Okay. So what is the lower limit? It's a 0. Are you getting?
Yes.
Okay. Now, so if you see here, I have to do 0 to x. So 0 to x lambda times e raised to minus lambda x dx. I have to integrate this part, right? Lambda I can take outside. So I will be having 0 to x e raised to minus lambda times of x. Okay, did you get this limit part, right? 0 to x, because this is the upper limit, right? What is the lower? Lower is 0. In case of uniform, we had a to x because we know in case of uniform, it was more than a and less than equal to b, right? Now, so lambda, what is the integration of e raised to minus lambda x? Anyone? No?
Minus lambda
It's
raised
nothing
to
but I'm just writing. You can search. It's the e raised to minus lambda x. So we have to divide by the constant minus lambda. It's 0 to x. Okay. Now lambda will get cancelled out. You will be having minus. It will be e raised to minus lambda x 0 to x. So at the end, if you see what we will be minus, if you put x, you will get minus lambda x minus e raised to, it will be 0, right? And something power 0, that means 1. So it was minus lambda x minus 1. Minus will get inside the bracket. It will be 1 minus e raised to minus lambda x. So this is the CDF of exponential distribution. Okay, this is something you can keep in your mind. Okay, so this is CDF. If I will ask, tell me probability x greater than x, then that means what? I can write 1 minus probability x less or equal to x,
Yes, sir.
right? That means what? 1 minus, what is the probability x less or equal to x? 1 minus e raised to minus lambda x, right? Then 1 minus 1 plus e raised to minus lambda x, 1 will get cancelled out. We will be having e raised to minus lambda x. So basically, what we will have here, e raised to minus lambda x. So you can see, if I will ask, what is the probability that x will be more than 10? You can simply put e raised to minus lambda times 10. So lambda will be given to you. Okay. Fine. So this is something, are you getting the idea? This is something you can keep in your mind, this CDF part and
Yes,
all
sir.
of it. Okay. And I will just write the formula of expectation and variance. So expectation of exponential distribution, nothing but 1 by lambda, and variance is nothing but 1 by lambda square. Okay. So you can keep in your mind, or if you want to do the derivation, you can simply do the derivation expectation of x as a something 0 to infinity x into fx ds. You will get the 1 by lambda itself. But I'm not going to do. I'm just telling you the formula here itself. I will more focus on the question part. Suppose I'm saying, okay. Suppose I'm just taking one example. Okay. Let me take one example from some activity. Where is the exponential? Exponential is here. Maybe that will give you more idea. So this exponential uniform is very, very important as point of real life as well as point of your exam itself. Okay. Now, okay, tell me tell me what will the value of k here? This is the question. Just see. Okay, to find the value of k, what you will do? If there is any constant in case of discrete, what we were doing? We were using the concept of valid PMF, right? We were adding all the probabilities equal to, and we got the value of some constant, right? So in this case, what you will do? To be a valid PMF, what is the properties?
We'll take it limit wise.
What I'm saying, to be a valid PDF, what is the properties? Okay, for being valid PM, what is the properties? Probability should be greater or equal to 0, and sum of the probability should be equal to 1, right? Yes or no?
Yes, sir.
In case of continuous, this fx should be greater or equal to 0, and integration throughout the range should be equal to 1, right? The same thing. The one instead of summation sign, we are going to use the integration sign. Okay.
Okay, sir.
Right? Are you getting my idea? What I'm trying to say? This is the property of being a valid PDF. Probability density function. Okay. So is this fine? These two properties okay to everyone?
Yes, sir.
Yes, no for all, or is it for only one? Is it okay to all? I want to listen from everyone.
Yes, sir.
Right? If you don't get, you're not getting or something, you simply let me know. Okay. So if you not acknowledge, then I don't think I will get some idea whether you are getting the point or whether you are understanding or not. Right? Okay. So here this is the constant, right? To know this constant, okay, if you see in the case of uniform also, we have to integrate throughout the range, right? So there is two things. So if what is the throughout the range? It's the 0 to infinity, right? It can take value 0 after 0 till infinity, right? So I have to integrate this PDF equal to 1, right? This is the property I will use. So 0 to infinity k into e raised power minus 2x dx equal to 1, right? So k I can take outside. It will be 0 to infinity e raised power minus 2x dx equal to 1. So k into e raised power minus 2x, and integration will be minus 2. We have to divide. Should be 0 to 1. Everyone is getting this point, right? This is the basic integration. Okay.
Yes, sir.
So it will be k by 2 minus, or let's say minus k by 2. If you put infinity, it will be e raised power minus infinity minus e raised power 0, right? And e raised power infinity is what? 0, right? And e raised power 0, that is 1. So it will be minus, and minus minus will be plus. K by 2 is equal to 1. And this is nothing but k I will get as a 2, right? Yes or no? So value of k is 2. So here you can simply see f of x is will be 2 into raised power minus 2x, whether x is greater or equal to 0. So one more thing you can simply observe. This is the exponential distribution. Fx was what? Lambda e raised power minus lambda x greater or equal to 0. So in this particular case, if, okay, tell me, this is the lambda, this is the lambda, correct? What was the question? K into raised power minus 2x, right? And x was greater or equal to 0. So all the properties was the same as exponential. If this is minus 2, sorry, this is 2, then it should be 2, right? You can directly guess in this particular
Yes.
case without integrating. Yes or no?
Yes, sir.
Right? Now, So value of k is the 2. So my main focus is to the next question. Okay. So question is, let me write this question. So waiting time in a hospital. So here you can see again distribution of amount of time we are talking about. Okay. So question is waiting time in a hospital is said to follow exponential distribution with the expected waiting time of 10 minutes. Okay. What is the probability that a person visiting a hospital has to wait for more than 15 minutes? Okay. So what is the given to us? Let's say X is the waiting time in a hospital. I mean my random variable defined as the waiting time in a hospital. Okay. Then what is the given to us? It says it's X follows exponential distribution with some, let's say, parameter lambda. What is saying? Expected time of waiting time is 10 minutes. That means what? What is given to us?
E of x is
Expected of X is given to us 10 minutes, right? Yes or no?
Yes, sir.
And we know if X follows exponential distribution with parameter lambda, then what is the expected value of X? We have seen it's a 1 by lambda, right? You can see in this question we didn't give the direct value of lambda. It is saying in terms of expectation, right? It is saying expected is given to us. That means we know expectation is 1 by lambda. So that means 1 by lambda is 10. So lambda will be 1 by 10. That means 0.1. Okay. So now
Yes,
here I will say X follows exponential with parameter lambda is 0.1. Is this clear so far? Okay.
yes, sir.
Now, what is the main question? If you see here the main question, what is the probability that a person visiting a hospital has to wait for more than 15 minutes? What is the meaning of that? How will you write this in the mathematical form?
Probability X is
of
greater
x
than
greater
or is equal to
Yeah,
15.
X is greater or equal to 15, right? Yes or no? This means what? I'm going to write question is probability X greater than or equal to 15, right? Yes or no? This is meaning
Yes,
more than, right?
Yes.
So if you see, so I can write equal or I can simply, it's about more than, so you can write greater than sign in anyway, in case of continuous, this equality sign doesn't matter. Okay. If you see what we have write, if X follows, we know one more thing. If X follows exponential with parameter lambda, then what was the PDF? PDF is lambda into e raised to power minus lambda x. What is the CDF? It was 1 minus e raised to power minus lambda x, right? Suppose you don't want to integration or you don't know the integration. So can I write this as a 1 minus probability x less or equal to 15?
yes, sir.
Yes, sir.
Yes or no? And what is the x less or equal to 15? 1 minus, I can
Minus
write 1 minus,
one
because 1 minus e raised
e
to power
minus
lambda x, right? E raised to power, what is the value of lambda? 0.1.
1,
What is the value of x here?
15.
15.
Correct. So here I will get 1 minus 1 plus e raised to power minus 0.1 into 15. That means 1.5, right? So 1 will get cancelled out. It will be e raised to power minus 1.5. You can just simply put the constant value of e and power minus 1.5. You will get the answer. Is this clear? Are you getting the idea? See, without, you can simply see, without using integration formula, I can I will use direct the CD part. I will get the thing. Yes or no? Okay.
Sir, can you explain the parameter part?
Which parameter?
Sir, the above 0.1.
Okay. So in the question, right, this lambda was not given directly. In the question, you can see it is saying expected waiting time of 10 minutes. Okay. Rather than giving lambda direct, it can simply say lambda with parameter 0.1 minute, but here is saying expected waiting time. So that means expectation is 10 minutes, right? And we know
Right.
expectation of exponential distribution is 1 by lambda. So from here, I can find the value of lambda. Yes or no?
Okay.
Okay.
Yes, sir.
See, sometimes also given to us, let's say instead of expected waiting time, we simply say variance of waiting time is, let's say, 100 minutes, for example. Then what is the variance of exponential distribution? Expectation of exponential distribution 1 by lambda, variance is 1 by lambda square. If it is given that suppose variance is 100 minutes, that means 1 by lambda square is 100. Then lambda square will be 1 by 100. Then lambda will be 1 by 10. Okay. So it can be anything. Okay. But you need to identify whether lambda is given to us or expectation is given to us. But accordingly, we have to find the value of your parameter lambda. Is this fine?
Yes, sir.
Okay. So, okay, let's do this question. If, say, I told the one example of lifetime of battery. So, lifetime of battery is expected to follow exponential distribution with expected lifetime of 10 hours. What does this mean? Let's say I'm saying X follows life, X, I'm denoting X as the lifetime of battery. Okay. What is saying? Expectation of X is what? 10 hours, right? And it's mentioned X follows exponential distribution. Let's say I'm saying parameter lambda. I don't know the value of lambda. It's saying what is the probability that battery will last more than 10 hours but less than 20 hours. So what is the meaning of this?
Probability X is greater than 10 and less than 20.
Right? It means probability X is more than 10 and less than 20. And we know in case of continuous, if probability A less than X less than B is there, I can simply use f of B minus f of A. Right? Yes or no? So I can simply use here f of 20 minus f of 10. Right? And what is the CDF of a exponential distribution? 1 minus e raised power minus lambda x. Right? Okay. Right? This is the CDF form actually. Okay. This is the CDF of a. So what should I write now here? 1 minus e raised power minus. Tell me.
Lambda is 0.5.
And
Yeah. So here, okay. From here, I can find the value of lambda, right? So
1
expectation
by
value of is 1 by lambda is 10. That means lambda is 1 by 10, which is again 0.1, right? So it will be 20 into 0.1 by using this formula minus 1 minus e raised power minus 10 into 0.1. Yes or no?
Yes, sir.
Correct. So I'm using this CDF formula itself directly, right? I'm not going to do the integration part here. Fine. So what you will get here 1 minus e raised power what 20 into 0.1, what you will get 2, right? And minus 1 plus e raised power minus 1, right? 1 will get cancel out. So what you will add e raised power minus 1 minus e raised power minus 2. Okay. So I mean we have to just put the value, you will get the answer. So what I'm trying to say here, there is no need to do the integration part. You can simply do the f of 20 minus f of 10. You can simply apply the CDF formula and you will get the. Is this fine?
Yes, sir.
Right. So this kind of question is you can say important, right? You have to just be careful. You can simply do if this is the continuous, you can simply directly write f of b minus f of k if f of a if x is lies between a and b. Okay. So far so good.
Yes, sir.
Is that all right? Okay. Okay. So far it is fine for everyone.
yes, sir.
Okay. So I think how many of you covered had already covered till exponential, or it was new for all?
Sir, it's
It's new, sir.
New. Okay. Did you get some sort of idea how we are doing? What is the PDF form and how we are doing the basically that computation part and all? Okay.
Yes, sir.
Did you get
Yes.
some? Okay. Well, fine. So one more distribution is there called normal distribution. If you want, then we can discuss right now, or else we can discuss in the next session also. So what's your thought? Should we give some sort of idea for normal distribution, or should we move ahead?
Sir, for end term, like what will be important? Once can you say?
It's okay. So in term, the major portion will be from week 9 to 12. Okay, and some portion will be from week 1 to 8 as well. Okay, and in week 12, from normal distribution there will be only one question, because this time we have introduced normal distribution actually. So there will be only 2 mark question from normal distribution, but from week 9 to 12, rest will be major portion will be from 9 to 12. Okay, so let me discuss this normal itself. So I have taken the slides of ma'am itself, so that I will give you some sort of idea. Okay, let me just discuss so that you can get idea some sort. Okay, so this is something shape of normal distribution. Okay, so this shape of normal distribution is actually it's the bell shaped curve. It is symmetric about mu. Okay, mu means how we are writing normal distribution actually. So this is something information about normal distribution. So see, it's a PDF, probability density function of a normal random variable, is determined by actually 2 parameters, right? Okay, in case of exponential, we have seen, right? X follows exponential lambda. So lambda was what? It was parameter, right? Correct. In case of uniform, we have seen a comma b. Then a and b was parameter, right? So similarly, in case of normal distribution, it says 2 parameter. One is called mu and another is called sigma square. So this mu is nothing but expected value of x, and sigma square is nothing but variance of x. If I'm writing x follows, so notation for this, x follows normal mu comma sigma square. So this mu means nothing but this gives you expectation of x, and this sigma square nothing but this is gives you the variance of x. Okay, in case of here itself normal distribution. Okay, now, and what is the, see, if you see, there is one particular form of PDF in case of exponential distribution. It was lambda into e raised power minus lambda x, right? And x was greater or equal to 0. So normal distribution, PDF of normal distribution is this. I mean, this is the one particular form of PDF for normal distribution. It's a 1 upon root 2 pi sigma. This is called sigma. This notation called sigma square. E raised power minus x minus mu whole square divided by 2 sigma square. Okay. And don't worry about this difficult formula, whether you to keep in your mind or not. Okay. If you don't know the, I mean, if you know, that's very good. If you don't know, then there is, I mean, there's no need to worry, because in normal distribution, without integration, we are doing the things, because this is very typical formula, right? It's a very little bit difficult. If you will do integration, it's very difficult. So in case of normal distribution, we are moving to the something called standard normal. I mean, we are using, I will let you know after some time. So actually, this is the shape of normal distribution looks like. Okay. So it's called, so what is the shape? It's called bell shaped curve. You can see it's like, seems like bell shape. Okay. Bell shaped curve. And it is symmetric about mu. I mean, this peak, right? This peak you can see it's about mu. Mu means it's a mean. So it's a symmetric means this part. Okay. This part is equal to this part. That means this is the 50% and this part is the 50%. Okay, this is something meaning of symmetricity. Okay, both part is equal. What do you mean by this equal? Suppose I'm saying this is suppose I'm saying this is minus a, for example, and suppose I'm saying this is a. So this part, this red shaded region will be same as this part. This is something meaning of the symmetricity. That means what is this red region? Can you tell me? Suppose I'm saying x follows normal distribution with mean mu comma sigma square. What is this? What is this shaded region? What do you mean by this shaded region? How will I mean? I mean, how will I write in terms of mathematical form? Can I write probability x less or equal to minus a something? Yes or no?
Yes, sir.
And what about this part? This will be probability x greater or equal to a, correct? Okay. So due to symmetricity at mu, okay, we will be simply say probability that x less or equal to minus a, this will be same as probability x greater or equal to a. So this a can be anything. It can be -2, it can be -1.5, okay, it can be 1.5, anything, right?
Yes, sir.
No, sir, I'm not getting this.
Sir, you are not audible.
Okay, so this a you can treat as, okay, this a will be basically nothing but it's something mu minus a. Okay, it was incorrect. It's a mu plus a. Fine. Okay, because it's the distance from this mu. Okay, mu minus a and mu plus a. So main point is this, due to symmetricity, right? This part will be same as this part. Okay. Basically, this is okay. So what tells you this probability x less or equal to mu minus a. This will be same as probability x greater or equal to mu plus sigma. Sorry, mu plus a. Okay. So this mu minus a is nothing but this point, point which I have highlighted here, and this mu plus a is nothing but this point which I have highlighted. Is this fine? Okay.
Here we are taking x.
X is a normal. This is the one parameter is called expectation of x. This is the variance of x. Okay. So you can see this is the bell-shaped curve. See, let me erase all these things. This is the bell-shaped curve. Okay. Fine. So this covers the 50% part of your graph, and this will cover the 50% of your part. Okay. So total area under the curve will be 100%, or you can simply say in terms of probability, area under the curve, probability of area under the curve, it will be 1. Okay. Is that all right? So these are some graphs. You can see whenever you will change the value of mu and value of this sigma, you will get different kind of graph. You can see for sigma 0.5, you will get some different graph. Sigma equal to 1, sigma equal to 2. So this sigma is nothing but it denotes the standard deviation. Standard deviation or means basically it will tell you the spreadness of your data set. I mean how much your graph is going to be flatter, right? Or what is the spread out is there in your distribution. Okay, understood? So this you can see mu as -2. Okay, so this was here sigma is the same, sigma square is the same, here variance is same, but for different mu I'm getting the different graph. Okay, for mu is equal to -2, this is the graph. I mean it's basically gives you the peak at -2. This will give you peak at 0. This will give you the peak at 2. Fine. Okay, the same thing I told you, right? It's a symmetric about expected value. So that means this region will be same as this region. Yeah, you can see. So this, whatever the probability for this will be same as this property, because due to symmetricity, it's a symmetric curve. It's not any skewed curve. Okay. So similarly, you can see here. Okay, let me cover one more point. Okay. Yeah. So this is something called this is very good thing. It's called approximation rule. What? It's a very important case of normal distribution. Suppose I'm saying x follow normal with mean mu and variance sigma square. So it has been already verified. We are not going to the derivation. What if x will be from between mu minus sigma and mu plus sigma? So it covers approximately 68%. Okay, that means so this is the mu minus sigma, right? And this is the mu plus sigma. So it will cover approximately 68% of the region. For 2 standard deviation, that means mu minus 2 sigma, and till mu plus 2 sigma, it will cover the 95% of the total. When we will move to the 3 standard, so it will be mu minus 3 sigma and mu plus 3 sigma, it will cover the approximately 0.997. So whenever you will get some probability, right, if you will convert in standard normal form, if you are getting the probability, let's say z greater or equal to 4, so it will be approximately 0. Okay, because in case of standard normal distribution, we will be getting this as a -3 and this is the 3. So from -3 to 3, you can see we are getting the probability at least 0.997. So after this point, it will be approximately 0. After this point, below this point, it will be probability, it will be approximately 0. Okay.
So if we get more than -3 to 3, then all the probability will be 0.
Sorry, could you repeat?
So if we get probability more than -3 to 3,
Yes,
positive
more
3,
than 3 and
then
below 3, below -3.
below -3, then
Yes,
every probability will be
will be
0.
approximately 0. Yeah.
So why we are considering,
Yeah.
okay, we have calculated the value
Yeah,
by
it's
putting,
already, yeah, derived one. Okay, let me tell you
okay,
something more. What I mean by that is standard normal form. Okay, these are the some basic questions which you can see. Okay, so like whatever you can see, something this is x less than 95 means what we have to be. I'm asking about less than region part. Okay, so let me go to that part, standard normal form. Yeah, I was discussing, right? Okay. So you can see, right? I was telling you that standard normal form -3 to 3. So you can see after 3, right? So probability is approximately 0. And here below -3, it will be probability less than, whenever I will talk about, let's say probability z less or equal to -3 or let's say -4 something, it will be approximately 0. Okay. So you can see in the, whenever our x was here, peak is at mu equal to 0, right? When I'm writing x follow normal mu comma sigma square, then peak was at mu. Okay. In standard normal form, it become mean as 0 and variance as 1. So you can see simply peak as at 0 itself, right? So whatever value, suppose I'm writing here this one -1 is there, right? If I will write -1, okay, then probability z less or equal to -1 or probability z greater or equal to 1. So these both probability will be same, okay, because of the, due to this symmetricity. Okay, fine. You can see that this same approximation rule. Okay, we were discussing mu minus sigma, mu plus sigma, right? For mu minus sigma to mu minus sigma, it was 0.68. Here mu is 0, variance is 1. So it will be -1 to 1 as 0.68. Then mu minus 2 sigma, this is nothing but mu minus 2 sigma, and this is nothing but mu plus 2 sigma. So mu is 0, where sigma is 1, so it will be -2 to +2. So approximation rule is the same, just we have converted our normal random variable, x, to as a standard normal form. Okay, fine. So you can see simply this value, probability z, z is lying between -2 to 2. Okay, so this is something this, and we are asking about this case. Okay, so you can simply tell, we know from for 2 standard deviation, right? So it covers approximately 95%, right? Or you can say in terms of point, you can simply say 0.95. So this is nothing but -2 to 2. I can directly write the 0.95. Okay. Okay, is this clear till now? Yes, no, anything? Is this fine?
yes, sir.
Okay. So, okay. Let me tell you one more thing. After that, you can simply watch the lecture video, then we can discuss more on it. Okay. Maybe then after that, you will be having an idea. Okay. Okay. This part, right? I told you, right? This part. So we had seen this probability A less or equal to X less or equal to B, right? Then we have seen probability x less or equal to b minus probability x less or equal to a, right? We have derived also. So here you can see if there is any question, it is asking about probability a less than j less than b. I can simply write probability z less or equal to b and minus probability z less or equal to a, right? So here equality actually doesn't matter in case of continuous, because probability at a singleton point it will be 0. Okay. So this is something here you can directly use there is something called standard normal table. Okay. So from there, see, instead of integrating and all, you can simply see the value from there, and you can simply put the value. Okay, let me just show you that table itself. Maybe it should be in the slides. Okay, this is the table. For example, suppose question is probability, you got probability G less than zero point 0.1. Okay, that means what? So this is the 0.1, and at 0 there is nothing something, so at 0, so value will be directly 0.5398. Okay, if I will ask probability z, suppose I'm saying this are less than 0.12. Okay, so 0.12 means what? This is 0.1, and what is the 2? This means this case, so this will be the correct answer. Okay, suppose I ask what is the probability z less or equal to, let's say, 0.74. So 0.7 is this case, right? 4 we have to see from here. This is the 0, this is the 0.71, 0.72, 0.73, 0.74. So this will be your answer. Okay, so this is something we can check this standard normal table. Actually, this gives you the value at this CDF of your normal distribution, standard normal distribution. Okay, so whenever is this case, right, this less or equal to case, make sure it gives the form of CDF, that means FZ. Okay, FZ means probability Z less or equal to Z. If in case, suppose you have been asked what is the probability Z greater than 0.12, you can simply do 1 minus probability Z less or equal to 0.12. Then you can simply find 1 minus, and this value Z less or equal to, it will be 0.5478. So make sure it always gives you the value at a less than equal to sign. Okay, fine. Okay, this is the whole normal standard normal table. This is something you can find from the in Google and all. Okay? Here you can see probability z less than 2.2. No need to do any integration or something. You can simply find the standard normal. So one thing I forgot to mention to, so how to calculate, actually convert in standard normal. So suppose I'm saying x follow normal mu comma sigma square. So standard normal means I'm denoting z is nothing but whenever I will subtract x minus mu divided by sigma, this is called standard normal form. This is called basically standardized form. Okay, and this is normal 0 comma 1. So mean will be 0, variance will be 1. Okay, so how will you get this one? I mean, basically, okay, so see, x is nothing but normal mu comma sigma square, right? And I told you x minus mu divided by sigma, it will follow normal 0 comma 1. So this mean is nothing but okay, so you can simply apply the linearity property. So expectation of z means what? Expectation of x minus mu divided by sigma. Okay, and we know expectation of ax, a is constant, so it's nothing but a times expectation of x. So this 1 by sigma I can take outside. Okay, so it will be x minus mu, so it will be 1 by sigma. What is this? I can simply write expectation of x minus mu. Okay, and what is the expectation of x? What was the expectation of x? It was mu itself. So we got mu minus mu divided by sigma. This is 0. So this 0 is from here itself. Okay, fine. And for the variance, variance of z means what? Variance of x minus mu by sigma. And you know variance of 8 times x is what? If a is in constant, it's 8 square variance of x. So it will be 1 upon sigma square variance of x, right? Sorry, x minus mu. And it will be 1 by sigma square. And we know if you add or subtract any constant, variability doesn't affect, right? So it will be variance of x. And we know what is the variance of x, sigma square divided by sigma square, which is 1. So this is something we got from here. Okay, is this clear? Where we got this 0 and this one? Fine. Okay. So just go through this normal distribution lecture video. Okay. You will get the more idea, and rest thing we can discuss in the upcoming session. Once you will see all the concept, we can discuss more on. Okay. Fine. Okay. Okay, then let's close this session. Okay, we can. I think Sunday is uh, another session. We can discuss there. Okay, fine.
Sir, what proportion week will cover the end term exam? 9
Okay, so
to 12.
okay, major portion will be from 9 to 12. Exact week wise, like percentage, I will share the soon. Okay, maybe in next session I will share. Okay, I need to check. But
Okay.
make yeah, it's of course major portion will be from 9 to 12, and less portion will be from 1 to 8. Okay.
You can check.
Okay.
Okay,
Yeah.
sir.
Fine. Okay. Okay then. Thanks.
Thank you,
Thanks
sir.
all. Thank you. Bye.
Thank you, sir.
Okay. Thank you. Thank you. Bye.